Hello friends, greetings to all of you for taking the tests for preparation of placements. I congratulate each one of you who have been engaging yourself during this lockdown period for preparing yourself or getting ready for employment and better career purposes. Hearty congratulations. I also thank my colleagues who have been working from home to prepare the ground for your preparation and training on a day-to-day basis in a relentless manner. Thank you, friends. Now, as part of the trainings, it is appropriate to provide solutions for the questions in the technological domain or the domain subjects that are given. From my side, I am providing solution for the computer science related domain questions that are given by the faculty, collecting these questions from various resources and various placement drives, both in direct and indirect means. Fine, let us start the solution. First, test that was conducted. Question number 49. I'll read the question. In the next slide, I'll show the solution. Explanation is given. And lastly, answer is given. That is the approach. Let's see now. Question number 49. I have a problem to solve which takes as input a number n. The problem has the property that given the solution for n minus 1, I can easily solve the problem for n. Which programming technique will I use to solve the problem? Here, what is being questioned, what is being asked is the approach to the problem. Right? Let's see the explanation before going to the answer. Lastly, we'll get the option correct. Right? Solution. When a problem can be expressed in terms of previous instance of the problem, that means the problem itself is redefined as it's a previous instance. Solution can be found by solving the problem up to the previous instance and then adding the solution for the current instance. This technique is called defining the problem recursively, and the approach is called as recursion. Recursion is one of the most powerful means of programming where a problem is to be solved in a cyclic manner. For every instance of it, the problem is to be solved. So the answer is recursion. Option D is correct. I'll take the second question. Question number 50. Pankaj and Maithili were both asked to write the code to evaluate the program following expression. A minus B plus C by A minus B, which is in the bracket, plus A minus B square or A minus B raised to power 2. Pankaj writes the following code segment and it is called as code A in the problem, which is given as print A minus B computed first plus C by A minus B plus A minus B into A minus B. Maithili writes the following code statement. It is called as code B now. D is equal to A minus B. That means Maithili computes A minus B and stores in a memory variable called D. If the time taken to load a value in a variable for addition, multiplication, or division between two operands is same, that means the time taken to access the variables is one and the same. Which of the following is true? The question is on which program is better program. So we'll go to the explanation, we'll see the solution and come back to the option. Now, the solution. Now, as you can see, in case of Pankaj's approach, what is happening is he is writing the program in such a way that A minus B is computed several times. Every time A minus B is written, 4 times it is written. That means 4 times A minus B is computed because it is in parenthesis. It takes highest precedence. So to compute this, A is accessed, B is accessed 4 times each from the memory, which means that the time taken to access the variables is higher in case of Pankaj. But as far as memory is concerned, he is managing the expression with the two variables only. Right. Now, in contrast to that, what is happening in case of Maithili's approach is that, as we said earlier, Maithili computes A minus B first and stores it in memory variable, which means that Maithili is using one variable extra than that of Pankaj's approach. So there is one memory location extra used by the program written by Pankaj. Now, coming to the other part, when you see the print statement, A minus B is replaced by D, which means that 4 times D is accessed. So you can see straight away that the number of accesses to memory is drastically reduced. Precisely 50% reduction is there in the memory access through the program written by Maithili. So Maithili has written better program from time consumption point of view, a little bit not so better program from memory point of view. But look to the options. It is about code A versus code B. Clearly, the option should be A, where it tells code A takes more time but less memory compared to code B. Now, what is it we have learned through this problem is the concept about something called as complexity. Or when we say what is the efficiency of a program is measured in terms of two parameters. First one is the memory occupied by the program, the memory it demands to run. Second one, the time taken by the processor to execute the program. First one is called as memory complexity. Second one is called as time complexity. First one is also called as space concept complexity. Now, a program should be written in such a way that it takes as low memory as possible and as less time as possible. But when it comes to comparison between these two, time complexity takes more precedence over memory, which means that someone may write memory occupying program, but it takes lesser time. That program is called as better program compared to these two. So the answer here is A. We'll go to the next question now. Question number 51. What is implied by the argument of a function? So the keyword in this question is imply. That means argument means something in its function. So what is that something? Is the question. Now, as all of you know, when a function is written, some variables are given to it for execution. But before a function can be executed, it has to be defined, which means that function has two stages. First stage is its definition with proper name and a list of variables that go into operation that are manipulated by the function. This stage is called as I said, definition. And the variables incorporated here in the definition are called as parameters. These parameters can be a copy of the value or the address location, original value itself going into the computation. Accordingly, it is called as call by value and call by reference in C programming language. Now, when a function is called in another function, the calling function invokes this function which is defined. At that point of time, again, parameters are given with their value or address as we said. And this set of variables now are called as arguments. So arguments are the variables passed to the function when it is called. So the option answer is A, and that is what is explanation, a simple explanation. A function has two phases. First, during its declaration, the variables are called parameters. Second, it's an invocation or calling. In the calling function, the variables are called as arguments. The question is on arguments. It therefore means that the parameters of a called function imply arguments in the calling function. So the answer is A. We'll go to the next question, question number 52. In a sequential programming language, code statements are executed in which order? Fairly simple question, very easy to answer. It is very clear, and the hint is given in the question itself. When you solve a problem, first of all, you have to identify the keyword. The keyword gives hint towards options, and filtering becomes easier, screening becomes easier, identifying the correct answer becomes easier. Now, the keyword in this question is sequential. Now, in a sequential programming, as we all know, the first statement written will be the first statement executed, and the last one will be the last to execute. Since we write on a paper or on a computer, we write one statement below the other. This approach is called as top-down approach. So the answer is B, top to bottom. Let's see the explanation or solution. The order of execution of a sequential program is always in the order in which it is written. Therefore, code statements are always executed from top to bottom. So the answer is C. Now, there is a note here. In a programming language, it is possible to skip the sequence and go to the point where we want the program to run. This should not be confused with non-sequential programming or sequential programming. These are called as like the branch conditions, the loop conditions that are written in a program are deliberate attempts by the programmer to change the order of execution of program. This should not be confused with non-sequential programming. They are definitely sequential programming, but the sequence is being defined by the programmer, and the programmer doesn't decide arbitrarily because the solution to the problem demands that jumping. These are used by the programmer. So no confusion there. Next question. A pseudocode is used. Assume that when two data types are processed through an operator, the answer maintains the same data type as the input data types. That means there is no data conversion. What is the input given? The same data type is maintained in the output also. Assume that all data types have enough range to accommodate any number. What is being told through this sentence is that there is no limit on the memory, a hypothetical situation. If two different data types are operated on, the result assumes the more expressive data type. What will be the output of the following pseudocode statements? Now you can see question is so long. There are so much superficial information that is given. All this is disguising information or confusing information. We can straight away write off the memory size, unlimited memory size being available, and the order of preference, order of execution of program. All these are not required. What is important is a question is on data type and what is the output generated. Is there any coercion or forced type conversion or implied data conversion depending upon the operation? First of all, let us see what the operations conducted are. Four variables are declared: integer A, B, C, and D. A is initialized to 456 and D is initialized to 10. B and C are computed values. Now what is given in the statement? B is equal to A by D, C is equal to A minus B, print C. So the value of C is to be seen here. Now we'll see the explanation. What is the solution here? The solution is given this way. It is given in the problem that the data type is maintained in the processing. The data type is maintained in the processing. Let us run the program the way the computer does. First, what is computed is b is equal to 456 by 10, that is equal to 45. Now you see, actually 456 by 10 is equal to 445.6. Now what is happening? This 6 is getting truncated. This 6 is getting truncated. 0.6 is getting truncated. Why? Because you can see the program, all the variables are declared as integers. So truncation takes place. So B will store 45 only. Now C is equal to 456 minus 45. And that is definitely 411. So the option is D here. We'll go to the next question. We'll go to the next question. Question number 54. That is over. This is just now we have completed this problem. We'll go to the next question. Geeta takes as input two integer numbers a and b, whose values can be between 0 and 31. She stores them as 5-bit numbers. Remember, 5 bits are enough to store number up to 31 because the largest value that can be stored with 5-bit numbers is 2 power 5 minus 1, that is 31. She writes the following code to process these numbers to produce a third number. C is equal to 2 times a minus b, the difference between a minus b. Now the question is how many bits are required? In how many minimum bits should Geeta store C? A very good question indeed. We'll see the answer now. We'll go through the answer with an explanation. Now, let us understand this problem in two cases. Case 1, a greater than b, both a and b are positive. So what is the largest value possible for a? A can be at most 31, while least positive value for b is 0. That gives a minus b is equal to 31, which can be stored in 5 bits. And 2 times of a minus b now, that is 2 times of 31 is equal to 62. Now 62 requires 1 bit extra. So when two numbers are multiplied, the product can be sum of the number of digits in both numbers put together. So double the memory size is required. 62 requires 6 bits. Is the answer over? No. We have to see the other extreme also. Now we'll take case 2. A less than b with a negative and b positive. A can be at a least of minus 31, while the least positive value for b can be 0. Then what happens? A minus b is equal to minus a minus b, that is minus 31 minus 0, that is 31 minus 31 now. And 2 times of minus 31 is minus 62. Now you see, where do we store this sign bit? With 62 being the answer in both the cases, 6 bits are enough. So to store the sign bit, one more bit is required. So the minimum number of bits required to store the result is 7. The answer is B. We'll go to the next question. An 8-bit signed integer has the following range. The range is given. Fairly simple question. And the range is given as 2 power n, where n is the bit. But since it is signed bit, 1 bit will go for sign bit. So 1 bit is reserved for the sign. That leaves 7 bits to store the magnitude of the integers. What is the largest number that can be stored? 2 power 7 minus 1, 127. And the smallest number that can be stored is minus 2 power 7, that is equal to minus 128. The range, therefore, is minus 2 power 7 to 2 power 7 minus 1, that is minus 128 to 127. Now a doubt may come. Before we go to that, the answer is before that. Now come back to the doubt. With the positive integer, we have taken 2 power 7 minus 1. But with the negative value, negative sign, we have gone up to 2 power 8, 2 power 7 rather, minus 128. Why should it also be minus 127? No, in signed integers, when it comes to 0, there are two zeros, plus 0 and minus 0. Now, minus 0 has no meaning. So, what is done is that minus 0 is replaced with minus 128. That's why it is minus 128 to plus 127. We'll go to the next question. What will be the output of the following code statements? Now, we'll take another question. What will be the output of the following code statements? Integer x is equal to 34.54, y is equal to 20, z is equal to minus 5. And what is to be computed? A combination of relational and logical operators. Print y greater than 50 and z greater than 10 or x greater than 30. Now we'll solve this program. We'll do the program in a stage by stage manner to find out what the output can be. Now, no, we'll take another question, question number 56. What will be the output of the following code statements? Integer x 34.54, y is equal to 20, z is equal to minus 5. Print y greater than 50 and z greater than 10 or x greater than 30. We'll solve this problem by running through this program step by step. The expression is evaluated in the following way. Expression and value. First stage, y greater than 50, false. Next, z greater than 10, false. You can see this. And y greater than 50 and z greater than 10, false again. Now, the last one, x greater than 30, true. And the final expression, y greater than 50 and z greater than 10 or x greater than 30, which is 0 or 0 or 1, 0 and 0 or 1. 0 and 0 is 0, 0 and 1 is 1. So the answer is 1. B is the answer. We'll go to the next question. Pankaj makes a program to print the product of cubes of first 10 whole numbers. She writes the following program. Integer x is equal to 0, statement 1. There are 6 statements given. Integer sum is equal to 0, sum also initialized to 0. See the way variable is named here. The problem is to find the product of cubes and the variable is declared as sum. It's not good programming practice. Now, that aside, we'll go to the problem. While x less than 10, sum is equal to x star x, which is x cube. X is equal to x plus 1, x incremented, print sum. In her program, is her program correct? If not, which statement will you modify to correct it? Now we'll see again. We'll run this loop like previous problem. We'll run this loop and try to find out how the program is executed. The problem is to find the product of cubes of whole numbers from 1 to 10. So what should be the expression? Sum is equal to sum star x, with the sum being updated with new value multiplying the previous partial product, that is calculated, or partial product of cubes that is created, or equivalently it should be sum star is equal to x star x star x. Now let us take some values. X is equal to 0. Sum computed as per the program. Expected value of the program as it should be if we go by the problem product of cubes. X is equal to 0. Sum computed is 0. And expected value is also 0. 1, 1 into 1 into 1. So 1. Now what happens in case of original, the actual program is sum star is equal to x star, x star, x star. What was sum initialized to? 0. 0 into 1 into 1 into 1, 0. 2, again, 2 cube, 8 is computed, 0 is coming. 3 cube, 27 as per the program written, but it becomes 0 as per the initialization. Now, where is the error? There are actually two errors in this program. First one is statement 2 where sum is initialized to 0. The basic approach to programming or basic idea, the thumb rule is that whenever we have to calculate the sum of some numbers, then we initialize the variable to 0, sum or difference. But when it comes to multiplication or division, we initialize that value to 1. It should not be to 0 because everything multiplied to 0 will be 0 only. So that's the first mistake. Second one, in the computation of sum, updation is missed by the programmer. So there are actually two mistakes in the program. But among the options, statement 4 is given. So answer is C. We'll limit our discussion only to the extent of this problem. And the option is D here. Option is C. Sorry. Option is C. But truly speaking, there are two mistakes in the program. Right. Next, we'll go to the next question. The last question. Question number 58. Given integer x is equal to 40, y is equal to 35, z is equal to 20, and w is equal to 10, comment about the output of the two statements. Print x star y by z minus w, print x star y by z minus u, that the difference between z minus u is dividing now. Right. We'll see. Again, to understand this program, we'll go by the way we did for previous two problems. Given that x is equal to 40, y is equal to 35, z is equal to 20, and w is equal to 10, all are integers. So, truncation takes. I need not tell again about it. First step, x star y. So, I have made a tabular column. Step 2, print statement 1, print statement 2. According to print statement, for comparison purposes, I have made it very simple, table looking. Step 1, x star y is computed first because there are no parentheses. Precedence is multiplication. So 1400, but in the case of program statement 2, print statement 2, z minus u is computed first. We'll go through print statement first and print statement 2 in that order. First, print statement 1, x star y is equal to 40 into 35, that is equal to 1400. X star y by z is equal to 1400 by 20, that is 70. Now, lastly, step 3, x star y by z minus w is equal to 70 minus 10, that is equal to 60. Now, come to the second statement. Z minus u is computed first because parenthesis, the broad mark will say parenthesis, highest preference. So, z minus 2 is 20 minus 10 is equal to 10. Next, multiplication. X star y is equal to 40 into 35, that is 1400. And x star y by z minus w is 1400 by 10, 140. So in the second case, the magnitude, the result is higher, but the question is on difference. So what is the difference now? 140 minus 60, that is 80. So both the statements differ by a value of 80. And the answer is A. Thank you, friends. We'll meet again with the solution for another set of tests that you have taken. So, bye.